As software developers, we have probably came across the terms or the names PMF, Cdf, and the exponential distribution. There is a thin line that connects them, but I want first to start with the definition of each from the basics, as if we know nothing, and what is the thin line that connects them all. The PMF is the probability mass function. Basically, it would answer this. If you look at the street and you see cats going by, here we see many cats going by, and you ask what is the probability that the color of the cat that will go by is going to be white. And let's say with that we have three colors, white, black, and gray. So we can look empirically on what's going on the street, how many cats are black, how many cats are white, how many cats are gray, and decide for ourselves that the distribution, if we see a third of the cats are white and they all walk randomly, then we can say that the probability of the cat being walking is white is 1/3. And basically you could draw a graph where on the x-axis is the color of the cat, we have only 3. And on the y-axis is the probability, so it's going to be 1/3 for each, coming into 1. 1/3 plus 1/3 plus 1/3 is 1. Okay, so this is the probability mass distribution. As we see, it's mainly focusing on distinct values, and we did have here distinct values. We have a white cat, a black cat, and a gray cat. It breaks apart when we have too many values. For example, the weight of the cats. So if the weight of the cat can be 4.539 and the weight of the next cat is going to be 5.120, and the weight of the next cat is going to be, it's going to be a small cat, a kitten. So it's going to be 1.521 kilograms. Then it now much less makes sense to calculate the probability of the exact weight of the cat. It's going to be makes much more sense to calculate the percentile of the weight of the cat. So we can say that the next cat is going to be very heavy. Its percentile is 90 percentile, so it's heavier than 90% of the cats, or the reverse. This cat is weight is in the 90 percentile, so it's heavier than all the 90 cats. Okay, great. So this is actually the Cdf. In the Cdf, we calculate on the x-axis, we still have weights, but on the y-axis, it's the cumulative. This is why it's called Cdf, Cumulative Distribution Function. Because it's cumulative, we are calculating based on percentiles. How many cats have, what is the probability this cat would be heavier than 90% of the cats, or 50% of the cat for the 50 percentile. And then we see that when we did these measurements, we looked at the world and we looked at the color of the cats and we looked at their weights and then calculated their probabilities. But then we ask ourselves, why do we need to do all these calculations? I mean, there are a lot of math functions. There is x to the power of y, there's x plus 6. You see, we see that there are an infinite number of functions in math. But there are a few functions that look really nice. For example, there is the exponential distribution, which is y is equal to e to the power of minus lambda times x. So let's put aside again a little bit all these letters, and if we look at this function, the exponential functions, it looks like a logarithmic one. It first starts very exponentially. It's like a function that shoots up and then slows down very, very logarithmically. So it starts by shooting up and then slowing down up to 1. So we limit it from the values of 0.1 by its definition, and here we have a functions that gives us something like a model, because it's not perfect. It's not going to be a perfect world situation, but it's a model, and if we plug in the correct numbers, then the only number that is left for us to plug in is the x, because e is known. Lambda is something that we should give to the function. Lambda is used for occurrences. So if we know that cats go over the street every half a minute, so lambda is going to be 0.5. We plugged in the lambda, we have e, and the only thing that is left is x. Then we can ask, what is the probability that the cat would walk after 60 minutes or after 30 minutes? This would give us the Cdf. So, because this podcast, we do not get into it, I mean, the thing that we want here is Pmf is simple enough to describe given a value, give me the probability. Cdf is also pretty easy to describe. Given value, give me the cumulative or the percentile distribution. And then we said that we have a lot of functions which can model the distributions. One of them is the exponential distribution. And we can use this function specifically for occurrences. So if we know that the cats go by the street every half a minute, then plug in the numbers into the exponential distribution and get the output as the Cdf. So if we plugged in 0.5, which means a cat walks down the street every half a minute, 0.5, half a minute, let's say, then the exponential distribution will tell us that the Cdf for 60 minutes is going to be specific value. Just we plugged in the numbers. So this was Pmf, value to probability, Cdf, value to percentile, exponential distribution, value to percentile, but for occurrences every half a minute, where we plug the half a minute to the lambda into the equation and we get back the Cdf based on exponential. Start shoots up, the graph shoots up, you should imagine it shoots up from 0 up to 1 because it's probability, and then slows down logarithmically. This was Pmf, Cdf, and exponential distribution. Thank you for listening and see you next time.